We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
A very good morning, good afternoon, good evening, good night, whenever you will see this video. Today we will understand the working principle of different types of engines like 4-stroke petrol engine, 4-stroke diesel engine, 2-stroke petrol engine, 2-stroke diesel engine. But first of all, I will start with the working principle of 4-stroke petrol engine. So first of all, we will make a heading indicating 4-stroke petrol engine. Now, first of all, we will understand the meaning of 4-stroke means what. 4-stroke means what? That 4-stroke means what? That 2 types of the engines are there. First one is known as a 4-stroke engine and another one is known as a 2-stroke engine. Now 4-stroke means what? That it is such an engine in which we are getting 1 power stroke by the complete 2 rotation of the crank. Now when crank will complete its 2 rotation, 1 rotation, second rotation. So after completion of 2 rotation, we will get 1 power stroke. Now power stroke means what? Right now just remember the word power stroke. Later you will realize when I will start my explanation what is the meaning of power stroke. But up till now for 4-stroke engine, what you will remember, 4-stroke means what? That we will get 1 power stroke. How we will get the 1 power stroke? By the complete 2 rotation of the crank. Clear the meaning of 4-stroke engine? 4-stroke engine means what? In 4-stroke engine, 1 power stroke is obtained. How? When crank will complete its 2 rotation. Now crank means what? That it is a piece of a rod which is fixed at one of its ends. Supposing if I will consider this type of rod, that is known as crank. Now that rod is fixed at one of its ends. Supposing that rod is fixed over here. That means that rod can rotate like this. So when crank will complete its 1 rotation, first rotation, then second rotation. So 2 rotations are done for the crank, and when 2 rotation will be completed by the crank, at that time within that we will get 1 power stroke. So that is the meaning of 4-stroke engine. So clear about the meaning of 4-stroke engine. Now in front of that, if you want to understand the meaning of 2-stroke engine, so how I can explain for 2-stroke engine? Same definition. What? It is such an engine in which we will get 1 power stroke. How? By the complete 1 rotation of the crank. Now once again we will consider that crank means what? Over here I wrote crank means what? It is a piece of a rod which is fixed at one of its ends. So that is the supposing crank. Crank is rotating. When it will complete its 1 rotation, that means crank has completed its 1 rotation, and within that 1 rotation, what you will get? You will get 1 power stroke. That is the working of 2-stroke engine. So simply what you will remember, 4-stroke means what? 1 power stroke you will get. How? When crank will complete its 2 rotation. 1 rotation, second rotation. Within that 2 rotation, you will get 1 power stroke. 2-stroke engine means what? When crank will complete its 1 rotation, and within that 1 rotation, 2-stroke engine will produce 1 power stroke. So that is the basic difference between 4-stroke engine and 2-stroke engine. Now after onwards, we will start with the working principle of 4-stroke petrol engine. But before starting the working principle of 4-stroke petrol engine, again we will see first of all its construction. We will understand the construction and then we will go for the working principle. Then we will understand how 4-stroke petrol engine works. Achha. So in construction, different parts are there that you have to remember. The name of the first part is cylinder. Now cylinder means what? You can say like that, it is a hollow shaft. One shaft is there which is hollow from inside. Hollow shaft. Just like a glass. If I want to draw the glass, so I can draw the glass like this. Cylinder like this, which is hollow from inside. That means from inside it is empty. It has certain thickness, but from inside it is empty. And whose one end is closed and another end is open, just like glass. Whose one end is closed and another end is open. So that is the meaning of cylinder. Okay. Achha. Second part is your piston. Now piston means what? I can say like that, piston is a solid circular disc. So it is one type of disc which is solid circular disc. So that type of thing is known as piston, which is a solid circular disc. Okay. Now after that, what's happened? That piston is inserted inside of the cylinder. So if I will take that piston and if I will insert it inside of the cylinder, so I can draw this figure. That is your cylinder, and inside of the cylinder you are inserting one piston. Okay. Now from the front, if I want to see the figure from the front, so how I can see that same figure from the front? If I want to say, I can say like that, draw like this. That is what? That is your front view of cylinder, like this rectangular shape. That is your cylinder, which is a hollow thing. Inside of that cylinder, what we are inserting? One piston. So I will draw one rectangle which will indicate solid circular disc, which will indicate it is a piston. Clear up till now? In construction, first part is what? First part is what? It consists of one cylinder. Cylinder is in the form of a hollow shaft. After that, it has one piston. Piston means what? It is a solid circular disc. Now that piston is inserted inside of the cylinder. So this type of figure we can draw. Now that piston is connected with one rod. That rod is known as connecting rod. That rod is known as connecting rod. Why? Because connecting rod is used to connect the piston with the crank. So I will draw the crank. So this dark portion is known as crank. As I told you, crank means what? It is a piece of a rod whose one end is fixed and another end is rotating. So that end is fixed, and that last end of the rod is connected with the crankshaft, or you can say with the main shaft also. So I will use the word that last end of the crank is connected with the main shaft. Now main shaft means what? Okay, it is such a shaft on which power is produced. Now how power is produced, later we will discuss, but right now what you will remember, that connecting rod is connected with the crankshaft or main shaft, and main shaft means what? It is such a shaft on which power is produced. Okay, now that main shaft is connected at the rear tire of our vehicle. Okay. As for example, when you start your vehicle and when you will apply the accelerator, so first of all, which tire will rotate first? But obvious, rear tire will rotate first. Why rear tire will rotate first? Because rear tire is mounted on the main shaft, and that main shaft is located at the rear tire. That means that main shaft is present at the back side, and on the main shaft power is produced. So main shaft is rotating, and on the main shaft we are mounting one tire, and that tire is our rear tire, so that our vehicle will run. Achha. After that, connecting crank. That crank is located inside of one case, and that case is known as a crank case. So this portion is known as crank case. Okay. Now crank case means what? That it is such a device which will provide a protection cover to your crank, because as you know that crank is continuously rotating inside of this case, and if case is not present, so what's happened? There may be a chance of accident. So that is why, to provide a protection to that crank, one case is located, that is known as crank case. As for example, case means what? Supposing, have you heard about the word suitcase? But obviously you have heard. Suitcase means what? That whatever suit that you are wearing, that you are putting inside of one protection cover, that is known as your suitcase. Similar way at your house, showcase is there. What is the use of showcase? Certain trophies are there that you want to show to your guest. That trophies are known as showpieces. That showpieces you want to show to your guest. So that showpieces are locating inside of one case, and that is known as showcase. Showcase means what? It will provide the protection cover to your showpieces, just like trophy. Similar way, that is your crankcase. Crankcase will provide a protection cover to that crank. Okay. Acha. Now we will go on the top side. Acha. So which thing we have completed? First one is cylinder, then piston, then next is connecting rod, then next is crank, then next is main shaft, or you can say crank shaft. Okay. Next is crank case. Okay. Now one important thing, very important thing that we will discuss, that on the crank flywheel is located. Now I will draw first of all basic diagram of flywheel. That portion is known as flywheel. So important part of IC engine is flywheel. Now what is the use of flywheel? Now flywheel is such a device which will store the energy, and after that it will release the energy whenever it is required. Flywheel is what? Flywheel is such a device. First of all, flywheel will first of all do what? It will store the energy. First of all, it will store the energy. After storing the energy, what it will do? It will release it. It will release the energy. When it will release the energy? Whenever it is required. So flywheel is such a device which will store the energy and then it will release the energy whenever it is required. As for example, for flywheel, if I want to say, okay, have you seen, okay, exact meaning of flywheel, still you are not able to understand that, I know very well. So when we will start with the working principle, at that time, definition or meaning of the flywheel will be clear to you. But up till now, you should remember the definition of the flywheel. Later, each and everything will be clear. But up to this level, simply remember flywheel means what? It is such a device which will store the energy, then it will release the energy whenever it is required. Acha, if I want to say the example of flywheel in the old Bajaj scooters, if you have seen, when you will apply the kick, so beside of the kick, just beside of the kick, one rotor is there, white color or silver color. That rotor is also rotating when you will apply the kick. So that is not a rotor, but that is what? That is actually your flywheel. Later I will say the use of flywheel. Right now remember the meaning of flywheel. Clear up to that? After that, that main shaft is connected with one kick. On kick, what we are doing? We are applying the force. So that crank will start to rotate. That's it. That much thing you should remember up till now. What you will say? That main shaft is connected with the kick. On the kick, if you will apply the force, so what's happened? Engine will start like this, or ignition will start. On the top side of the cylinder, two valves are there. First valve is known as inlet valve and another valve is known as outlet valve. So over here, another part I will write inlet valve and second one is outlet valve. Now function of inlet valve is what? Okay, it is such a valve which will collect pure air and fuel mixture inside of the cylinder. So that is your cylinder portion. Or sometimes a pure air and fuel mixture is also understood by fresh charge also. So you can use the word fresh charge or you can use the word pure air and fuel mixture, but I will use one word. Which one? Pure air and fuel mixture. So function of inlet valve is what? It is such a valve which will collect pure air and fuel mixture inside of the cylinder. And the function of outlet valve is what? It will reject the burnt particles. After the combustion, whatever particles are produced, that particles are known as burnt particles, and that burnt particles will be rejected. Achha. Now, if you want to combust the fuel, if you want to fire the fuel, if you want to get the ignition of the fuel, at that time, it is possible by using one plug which is known as spark plug. So, use of spark plug is what? So, over here, I will write spark plug. Use of spark plug is what? Okay, it is such a plug which is used to provide a spark for the ignition of the fuel. Clear about that use of spark plug? Maybe you have seen spark plug also in your bike. So what is the use of spark plug? It is such a plug which is used to provide a spark for the ignition purpose or for the combustion purpose of the fuel. So this much important parts are there. Lots of parts are remaining like cam and follower mechanism, then fins, then piston ring, all that things. But up to this level, you should remember only that much part so that you can understand the 4-stroke petrol engine working principle. Okay. Acha, so first of all, what we are saying, first of all, we have understood the meaning of four-stroke engine. Four-stroke engine means what? कौन बोलेगा? Four-stroke engine means what? It is such a device in which we are getting one power stroke by the completion of two rotation of the crank. And two-stroke means what? Again, we are getting one power stroke by the complete one rotation of the crank. Okay. Now, before starting working principle of four-stroke engine, it is necessary for you to understand the construction of a four-stroke engine or petrol engine. Acha. Now, in construction, lots of devices are there. Important devices, which one? Cylinder. So it has one cylinder, which is a hollow shaft. Then it has one piston. Piston is a solid circular disc. After that, that piston is inserted inside of the cylinder. So its two-dimensional view will be like this. After that, piston is connected with one rod, which is known as connecting rod, because connecting rod connects piston with the crank. Now, crank is mounted on the main shaft. Main shaft means what? It is such a shaft on which power is produced. And main shaft is located on the main shaft, we are locating our rear tire. After that, main shaft is connected with the kick on which we are applying the force. Then connecting rod, with the connecting rod, crank is there. On the crank we are mounting one flywheel. Flywheel means what? Okay, it is such a device which will store the energy and then it will release the energy whenever it is required. Later I will explain how it will store the energy, how it will release the energy. Acha. After that, we have discussed about that case that is known as crankcase. Function of that crankcase is what? Okay, it is such a device which is used to provide a protection cover to your crank. Next is inlet valve at the top side of the cylinder. Inlet valve is there. Inlet valve means what? It is such a valve which will collect pure air and fuel mixture inside of the cylinder or fresh charge inside of the cylinder. That is your outlet valve. Outlet valve means what? It is such a valve which will reject burn particles. Whatever burn particles are there after the combustion, they are rejected by the opening of the outlet valve. Between inlet and outlet valve, one plug is present. Why plug is present? Because we want to combust the fuel, we want to ignite the fuel. So for that purpose, spark plug is used. So function of spark plug is what? It is such a device which is used to produce a spark for the ignition of the engine. So that is all about the construction of the four-stroke engine. Only four-stroke engine, you can say four-stroke petrol engine also you can say. Okay. Achha. Now our important part, which is what? Working principle of four-stroke petrol engine. Acha, if you are able to understand the working principle of four-stroke petrol engine, then automatically you can understand the working principle of four-stroke diesel engine. So concentrate properly, because one topic is done, automatically second topic you are capable to understand by yourself. Few differences are there, that differences I will say, and then you can understand properly. So now we'll start with what? With working of four-stroke petrol engine. Now, first of all, we will draw the diagram, because without diagram we cannot understand the working principle. So I will draw the diagram like this. Big diagram. That is your cylinder. Inside of the cylinder, one piston is inserted. Piston is connected with one rod, which is known as connecting rod, which is used to connect your piston with the crank. Crank is mounted on the main shaft. Main shaft is located with the kick on which we are applying the force. On the crank, one flywheel is located which will store the energy and then it will release the energy whenever it is required. Then at the top side of the cylinder, two valves are there, say inlet valve and outlet valve. Inlet valve will collect fresh charges or pure air and fuel mixture, and outlet valve is used to reject the burn particles after the combustion of the fuel. Between inlet and outlet valve, one plug is there which is known as spark plug, which is used to provide a ignition. Now, two positions are there. That two positions are very much important to understand regarding to point of view of working principle. Now, two points are there. First point is known as TDC. Now, TDC means what? TDC means top, dead, center. T stands for top, D stands for dead, C stands for center. Top, dead, center. Now, dead center means what? Have you heard about a deadline to fill the form? Deadline to fill the form means what? Supposing tomorrow will be the deadline to fill the form. That means After tomorrow, it is not possible to fill the form because deadline is given. Same way, that is the dead center which is top dead center. Above that dead center, your piston cannot travel. So that is why it is known as top. Above that, not possible to travel. So top dead center. That means maximum high position or maximum top position of the piston will be this, which is known as TDC. Comparatively, position of the crank, that is your crank. Position of the crank is also known as TDC. That means TDC means what? It is the position of the crank on which piston is present at its most topmost position. That is the meaning of TDC. TDC means what? Once again I will say. TDC means what? It is the position of the crank. It is the position of the crank on which, that means on that position, piston will be at its topmost position. That is the meaning of TDC. Clear about TDC? Acha. Now one more thing, as I told you that crank is rotating like this or in that direction. If you want to consider, you can consider, but that is a genuine direction. Acha. Supposing crank is rotating in this direction. So one position of the crank can I consider like this? Mirror image. If I will put mirror over here, so what's happened? Its image will be over here. Not actually mirror, but if I will extend this line, you can say like this. So that is one position of the crank. Now at that position, what's happened? Your connecting rod will be over here. Similar way, piston is connected with connecting rod, so piston will be over here. Okay. Now that position of the piston is known as BDC. Now BDC means what? Bottom dead center. So that is a dead center. Below that dead center, piston cannot travel. That is the meaning of bottom dead center. And comparatively, corresponding position of the crank is also known as BDC. Now BDC means what? It is the position of the crank. It is the position of the crank on which your piston is at its most bottommost position. So 2 points are very much important to understood. First point is which one? First point, what I saying? TDC. TDC means what? It is the position of the crank. Crank is present at this position, so that piston is present at its most topmost position. BDC means what? Crank is present at this position, so piston is present at its most bottommost position. So clear about the meaning of TDC and BDC? Sure? Clear? Achha. Now supposing over here if I will put one mirror, over here supposing if I will put one mirror, so what's happened? Mirror image will be over here for this connecting rod. Mirror image will be over here and correspondingly crank will be over here. So that position is also known as TDC. Similar way, if I will put one mirror over here, so what's happened? Mirror image of that crank will be over here and connecting rod will be over here. Getting what I am saying? Total 4 points we have discussed. First one is which one? TDC. TDC has 2 points. First point is over here on which piston is at its most topmost position. Second point is over here at which also piston is at its most topmost position. Achha. Now we have discussed about BDC. For first point BDC, at this position of the crank, piston is at its most bottommost position. Similar way, if I will put mirror over here, so mirror image of the crank will be over here and connecting rod will be over here and piston will once again present at its most bottommost position. So clear about this 4 points? Sure? Achha. After that, now actually we will start with working principle. How story works. Initially, what we will say. When over here I will make it dotted so that need not to confuse in this diagram. Okay. First of all, total 4 strokes are present, or you can remember like this: if your engine is 4-stroke engine or 2-stroke engine, in each and every engine, number of the strokes are 4. Number of the strokes are 4. If your engine is 2-stroke, then also how many strokes are there? 4 strokes are there. If your engine is 4-stroke, then also how many strokes are there? 4 strokes. Which 4 strokes are there? So first stroke is known as always suction stroke. Name of first stroke is suction stroke. Second stroke is compression stroke. Second stroke is compression stroke. Third stroke is known as important stroke, power stroke, that I told you before. We are getting one power stroke by the complete 2 rotation of the crank. That means it is the working principle of 4-stroke engine. So now that is your power stroke. In detail we will go, but up till now remember number of the strokes are 4. First one is suction, second one is compression, third one is power. The another name of stroke number 3 is also expansion stroke. Which stroke? Expansion stroke. And another name of stroke number 3 is also working stroke. So stroke number 3 has 3 different names. That 3 different names you have to remember. 3 different names are which one? Power stroke or expansion stroke or working stroke. And finally we will say stroke number 4 is exhaust stroke. Exhaust stroke. So total 4 strokes are there. This sequence is very much important to remember. Acha. First one suction, compression, power or expansion or working, and last one is exhaust stroke. Okay. So now we will start the working principle of IC engine. How will start? If you are able to explain this 4 strokes, that is nothing but the working principle of 4-stroke petrol engine. How will start? First of all, what we will say that when piston is on TDC, at that time inlet valve is open. When piston is on TDC, at that time what's happened? Inlet valve is open. So due to the opening of that inlet valve, what's happened? Pure air and fuel mixture will enter inside of the cylinder and piston will travel from TDC to BDC. When piston will travel from TDC to BDC, first of all, first question is what? How piston will travel from TDC to BDC? So I will say that with the application of the kick. When you will apply the kick? When you will apply the kick, so what's happened? Your crank will start to rotate like this, TDC to BDC. So when crank will go from TDC to BDC, so what's happened? Piston will travel from TDC to BDC. So that is why piston will travel from TDC to BDC with the application of the kick. And when piston will travel from TDC to BDC, at that time crank will complete its half rotation, because crank will also travel from TDC to BDC. And that half rotation is known as suction stroke. That is the meaning of suction stroke. Suction stroke means what? When piston is on TDC, at that time inlet valve is open, and due to the opening of that inlet valve, pure air and fuel mixture will enter inside of the cylinder and piston will travel from TDC to BDC with the application of the kick, and crank will complete its half rotation, and that stroke is known as suction stroke, because during that stroke we are sucking pure air and fuel mixture inside of the cylinder. So clear about the meaning of suction stroke. Okay, now remember one thing, in suction stroke we are sucking pure air and fuel mixture at constant pressure. At constant pressure. At constant pressure means what? Simply over here atmospheric air will enter and piston will move from TDC to BDC. That means pressure remains constant, only volume is increasing. Clear about that? So over here pressure remains constant and which thing is increasing? Volume is increasing. For what? For suction stroke. So that point you have to remember. In suction stroke, which process is taken place? In suction stroke, constant pressure process is taken place, which is atmospheric pressure, and when piston will travel from TDC to BDC, so but obvious its volume is increasing. Okay. Acha. Now when piston is present on BDC, that means I can say like this, after completion of suction stroke, because suction stroke will start from TDC and ends to BDC. So when piston is present on BDC or after completion of suction stroke, what's happened? Your inlet and outlet, both valves are closed. Okay. Then piston will travel from BDC to TDC. Now piston will travel from BDC to TDC. Now one question will come in our mind, okay, how piston will travel from BDC to TDC? Acha, initially you have applied the kick. So due to the kick, force of kick, your piston will travel from TDC to BDC in the suction stroke. When crank will reach over here at the position of BDC, then what's happened? So that crank will continue its rotation. So two things are there. First thing is what? Our flywheel. Now what I said, flywheel means what? It is such a device which will store the energy. So when crank is present over here, at that time you are applying the kick. By applying the kick, supposing you are transmitting 100 unit of energy. Among that 100 unit of energy, flywheel will do what? Among that 100 unit of energy, flywheel will only use 50% energy. And when crank is present on BDC, flywheel has stored still 50% more energy, and that 50% energy flywheel will release to travel from BDC to TDC. Clear about this point? How flywheel will travel from BDC to TDC? What actually we are saying? I am saying that when piston is present on TDC or when crank is present on TDC, at that time you are applying 100% energy by application of the kick. Among that 100% energy, that energy is transmitted to the flywheel. That means flywheel has stored the energy. Among that 100% energy, flywheel has used only how much percentage energy? 50% energy. That means still when flywheel is present at BDC, it has more 50% energy, and that 50% energy it will release to travel your piston from BDC to TDC. That is the first reason. Another reason means what? Another reason is known as moment of inertia. Due to the moment of inertia of the crank will keep continuous motion. Now moment of inertia means what? That steady object will be steady, and in motion object will keep continuous motion up to infinite distance under the absence of any external force. As for example, supposing if I will take one pendulum and if I will apply the force like this, so pendulum will start to oscillate. But if I will stop my finger, that means I am not applying the force, then also pendulum will keep continuous motion due to what? Due to moment of inertia. So over here, once crank has completed its half rotation, and after that crank has some moment of inertia, so that it will keep continuous motion, and crank will travel from TDC to BDC to TDC, so that piston will travel from BDC to TDC. Clear about these two things? First thing what I said, flywheel. When you will apply the kick, so on TDC you are supplying 100% energy to flywheel. Among that 100% energy, flywheel has used only 50% energy, and when flywheel is present at BDC position, still it has 50% more energy which is stored by the flywheel. So flywheel will release that energy, so that crank will travel from BDC to TDC and piston will travel from BDC to TDC. Second reason is what? Simple reason. Due to the moment of inertia, crank will continue its rotation. Like that you can say like this. So when piston will travel from BDC to TDC, so what's happened? Piston will impart the force on the air and fuel mixture that you have collected during the suction stroke. Because during the suction stroke, what's happened? Piston is traveling from TDC to BDC, inlet valve is open, so pure air and fuel mixture you have collected inside of the cylinder. After that, when piston is on BDC, both valves are closed. Then piston will travel from BDC to TDC due to the moment of inertia of the crank. And when piston will travel from BDC to TDC, at that time what's happened? Piston will increase the pressure and temperature. Pressure and temperature means what? Pressure, if you increase the pressure of something, so pressure is directly proportional to temperature, that you know very well. Pressure is directly proportional to temperature. So when you are increasing the pressure of air and fuel mixture, so temperature is also increasing, and piston will increase the pressure and temperature of air and fuel mixture up to distance of TDC. That means piston is right now over here. It will travel from BDC to TDC. When it will travel from BDC to TDC, at that time piston will do what? It will simply increase its pressure up to which position? Up to the position of TDC. That means crank has completed its one more half rotation. Which half rotation? BDC to TDC. So that is your BDC to TDC. That means during that traveling of piston, what's happened? Pressure is increasing, and as pressure is increasing, it is a compression process. So that is why that is known as compression stroke. It is present on BDC. Now when it is present on BDC, so due to the moment of inertia of the crank, piston will travel from BDC to TDC, and during that traveling of piston will increase the pressure and temperature of air and fuel mixture up to the distance of TDC, and crank will complete its one more half rotation, and during the traveling of piston from BDC to TDC, what's happened? Volume of the cylinder is decreasing, and if volume is decreasing, pressure is increasing. Volume is inversely proportional to pressure. If you will increase the volume, so what's happened? Pressure is increased. As for example, supposing if I have one water balloon whose volume is that much, and if I will decrease its volume, so what's happened? Pressure inside of the balloon is increasing. Same way over here you are decreasing the volume is decreased, So what's happened? Pressure is increased, and if pressure is increased, it is a compression process. So that is why it is known as compression stroke. Clear up till now? That means crank has completed its how many rotations? Only one rotation. And how many rotations be required? Two rotations be required. Acha. One rotation is done. Compression, suction and compression, two portions are done. How we have started? First of all, when piston is on TDC, inlet valve is open, pure air and fuel mixture enters inside of this cylinder. Piston will travel from TDC to BDC with the application of the kick, and crank will complete its half rotation, which is known as suction stroke, because during that stroke we are sucking pure air and fuel mixture. After completion of suction stroke, that suction stroke is done at constant pressure process, atmospheric pressure process, and volume of the cylinder is increasing. Okay. After completion of suction stroke, or when piston is on BDC, what happened? Both valves are closed and piston will travel from BDC to TDC. How? Due to the moment of inertia of the crank, or flywheel has released some energy. So that piston will travel from BDC to TDC. One point, that at this position, suppose at this position 100% energy flywheel has stored. Among that 100% energy, flywheel has used only 50% energy, and that 50% energy flywheel will release to travel your crank from BDC to TDC. That means when flywheel will reach once again on this position, at that time flywheel has how much energy? It has 0% energy. From TDC to BDC suction stroke, 50% energy is used. Then in compression stroke, from BDC to TDC, 50% energy is used. That means when crank will complete its one rotation, or when crank will complete its suction stroke and then compression stroke, at that time, at the end of compression stroke, flywheel has 0% energy. So then flywheel cannot move, because flywheel has used all its energy that it has stored. Okay. Now, when piston will travel from BDC to TDC, so what's happened? Piston will travel from BDC to TDC, and during that traveling of the piston, pure air and fuel mixture will increase its pressure and temperature up to the distance of TDC, and crank will complete its half rotation. And during this traveling of piston, what's happened? Volume is decreasing, so that pressure is increasing. That is why it is a compression process, so that it is known as compression stroke. Clear up to that? Now, so over here in compression stroke, what I can say? I will say that volume is decreasing and pressure is increasing. Am I correct? Volume is decreasing and pressure is increasing. Now, when piston is present on TDC, once again both valves are closed. But when piston is present at TDC, so what's happened? We will supply some spark. And when we will supply some spark, so what's happened? Combustion takes place. Why combustion takes place? Because when piston is on TDC, after completion of compression stroke at TDC, inside of the cylinder, whatever air and fuel mixtures are present, it has very much high pressure and temperature, and within that much high pressure and temperature of air and fuel mixture, if you will supply a spark, so what's happened? Combustion may take place, and due to the combustion, what's happened? Burned particle will produce. That burned particle will impart the force on the piston in the downward direction. It will also impart the force on the piston in the upward direction, but upward direction is rigidly fixed. So force which is exerting in upward direction is useless. So all the effective force is created in the downward direction, so that piston will travel from TDC to BDC. When crank is present on TDC, 0% energy is present. But over here, when it is present on TDC, what's happened? Power stroke is produced. Once again over here, 100% energy is produced. So that piston will travel from TDC to BDC, and crank will also complete its half rotation, because crank will also travel from TDC to BDC. And when crank will complete its half rotation, one more half rotation, so that is known as power stroke. Now, why it is known as power stroke? Because over here combustion of the fuel is taken place, and due to the combustion of the fuel, what's happened? Power is produced, or chemical energy of the fuel is converted in some power. So that is why it is known as power stroke. It is also known as expansion stroke. Why it is known as expansion stroke? Because power stroke is started from TDC. So at the starting of the power stroke, volume of the cylinder is that much only. And after completion of power stroke, volume of the cylinder is increasing. If volume is increasing, pressure is decreasing. And if pressure is decreasing, it is which process? It is expansion process. So that is why it is also known as expansion process. Finally, it is also known as working stroke also. Why it is known as working stroke? Because with the help of this power stroke, our vehicle is working. That is why it is also known as working stroke also. So clear about this power stroke also. Okay. Acha, in power stroke, actually what's happened? When piston is on TDC, at that time both valves are closed, and at that time pressure and temperature of air and fuel mixture is extremely high. And within that much high pressure and temperature of air and fuel mixture, if you will supply a spark, so what's happened? Combustion may taken place. Due to the combustion, what's happened? Burnt particles are produced. That burnt particle will impart the force on the piston in the downward direction as well as in the upward direction also. But upward direction is rigidly fixed. That's why all the effective force is created in the downward direction. So that piston will travel from TDC to BDC, and crank will complete its half rotation, which is known as power stroke, because chemical energy of the fuel is converted in some power. It is also known as expansion stroke. Why? Because at the starting of the power stroke, volume of the cylinder is less, and after completion of power stroke, volume of the cylinder is increasing. If volume is increasing, pressure is decreasing, and if pressure is decreasing, it is a expansion process. That is why it is also known as expansion stroke. And finally, it is also known as working stroke. Why it is known as working stroke? Because with the help of power stroke, our vehicle is working. Okay. Now, last stroke, exhaust stroke. How it works? After completion of power stroke, or when piston is on BDC, what's happened? Inlet valve is closed, outlet valve is open. In compression stroke, in suction stroke, inlet valve is open, outlet valve is closed. In compression stroke, both valves are closed. In power stroke, once again both valves are closed. In exhaust stroke, what's happened? Inlet valve is closed, but outlet valve is open. Achha. Now, when piston will travel from BDC to TDC, now how piston will travel from BDC to TDC? Once again I will say, due to the moment of inertia of the crank, piston will travel from BDC to TDC. So when piston will travel from BDC to TDC, what's happened? Whatever burnt particles are there after the combustion, that burnt particle will be rejected due to the opening of that outlet valve, and crank will complete its one more half rotation, and that half rotation is known as what? Last stroke, exhaust stroke. Why it is known as exhaust stroke? Because during that stroke we are exhausting the burnt particles. That is why it is known as exhaust stroke. Okay. Now we will observe the diagram. It is not observable, but still we will observe this diagram. In this diagram, what we can say that how many rotations crank has done? First of all, half rotation suction, remaining half rotation compression, one rotation. Then another half rotation power, last half rotation exhaust, two rotation. That means crank has completed its two rotation, and within that two rotation, how many power stroke we are getting? We are getting only one power stroke. So that is why it is the working principle of what? Four-stroke engine. Why it is a working principle of four-stroke engine? Because over here crank has completed its two rotation, and within that two rotation we are getting one power stroke. That is why it is the working principle of four-stroke engine. It is known as a petrol engine. Why it is known as petrol engine? Because in this engine we have used this spark plug. So that is why it is the working principle of petrol engine. Whenever spark plug is used, remember one thing, it is a petrol engine. And whenever crank will complete its two rotation, and within that two rotation if you will get one power stroke, that means it is the working principle of four-stroke engine. So two rotation, one power stroke, four-stroke engine, spark plug is used, petrol engine. So combinedly that is the working principle of four-stroke petrol engine. So clear about this? Acha. After completion of exhaust stroke, first one suction, compression, power, exhaust. After completion of exhaust stroke will be like this. Exhaust stroke will be like this. In exhaust stroke, what's happened? Pressure is increasing. Cam pressure is increasing because pressure is not increasing or decreasing, simply volume is decreasing. And as outlet valve is open, it will be rejected to atmosphere. When piston will travel from BDC to TDC, so what's happened? Outlet valve is open. So your burnt particles are exhausted. How? By increasing the pressure, like this, you can say like that. Or by decreasing the volume, because if you will decrease the volume, pressure will increase, so that burnt particles are exhausted. So in exhaust stroke, what's happened? Burnt particles are exhausted, but what's about volume? Volume is decreasing. Clear about that? In power stroke, what's happened? Power stroke like this, TDC to BDC. In power stroke, what's happened? Volume is again decreasing. Volume is in exhaust stroke, what's happened? Volume is increasing. volume is in hexostroke like this, volume is decreasing, and in power stroke what's happened, volume is increasing. In power stroke volume is increasing. Acha. When piston is on TDC, after completion of all 4 strokes, last stroke was what? Suction, compression, power, exhaust. In exhaust stroke what's happened, BDC to TDC. So when piston is present at TDC, so what's happened, outlet valve will be closed, inlet valve will be open, again pure air and fuel mixture will enter, again piston will travel from TDC to BDC, again crank will complete its half rotation, which is known as suction stroke, and again cycle will be repeated. So clear about this working principle. Simply which thing you will remember, in total 4 strokes are there if your engine is 4 stroke or 2 stroke. In 4 stroke, first stroke is which one? Suction stroke. In suction stroke what's happened, when piston will travel from TDC to BDC, inlet valve is open, pure air and fuel mixture will enter, crank will complete its half rotation, that is known as suction stroke. After completion of suction stroke, or when piston is on BDC, both valves are closed, piston will travel from BDC to TDC, so volume is decreasing, pressure is increasing, that is why it is a compression process, so it is a compression stroke. When piston is on TDC, what's happened, both valves are once again closed, pressure and temperature of air and fuel mixture is extremely high. Within that much high pressure and temperature of air and fuel mixture, if you will supply a spark, so combustion is taken place. Due to the combustion, burnt particle will produce, and that burnt particle will impart the force on the piston in downward direction, so that piston will travel from TDC to BDC, that is known as power stroke. Then after completion of power stroke, or when piston is on BDC, what's happened, outlet valve is open, piston will travel from BDC to TDC, whatever burnt particles are there, that will be exhausted in the surrounding, and cycle will be repeated. Clear up to that? Sure. If you have any doubt, again you can repeat this video, again you can understand. Achha. Now that is all about the working principle of 4-stroke petrol engine. One more thing, over here crank has completed its 2 rotation, and within that 2 rotation we are getting 1 power stroke. That is what is the working principle of 4-stroke engine, and in this engine we are using this spark plug. That is what is the working principle of petrol engine. So combinedly that is the working principle of 4-stroke petrol engine. Clear up to this? Achha. Now last thing, very important thing that I want to discuss, what? It's pressure versus volume diagram. That is very much important. Achha. Now that is your y-axis. On y-axis we are considering pressure in the unit of atmosphere. Okay. Right now pressure of the air is how much? We can say 1 atmospheric air is present. So supposing that is 0 atmospheric air, that is 1 atmospheric air. So over here how much dimension scale is what? 1 atmospheric air is there. Now that is point number 0. Understood what I am saying? That is point number 0. That is origin. Forget about this. That is O means 0 means point number 0. Point number 0 has how much pressure? 1 atmospheric pressure. Achha. I will draw one straight line like this. That straight line will indicate 0. Achha. 0 to 1. 0 to 1 indicates what? Constant pressure process. Constant pressure process. And volume is increasing. Constant pressure process. Volume is increasing. Constant pressure process. Pressure is constant. Volume is increasing from 0 to like that. Volume is increasing. That means what? Which process? Constant pressure process. Which stroke? Suction stroke. Why suction stroke? Because in suction stroke what's happened? When piston is on TDC, volume is increasing. When it will move from TDC to BDC, volume is increasing, but pressure is not changing. Pressure remains constant. So 0 to 1 is known as a constant pressure process, but name of the stroke is what? It is known as suction stroke. Clear about suction stroke? Achha. Now I will draw this type of curve. Okay. Little bit inclined it. Achha. Not straight axially. This type of curve, it is not a straight line, it is a curved line. Achha. Over here that is your point number 2. Okay. 1, 2, 2. Now in 1, 2, 2 what's happened actually? If I will say volume is decreasing. 1, 2, 2. Over here V1 volume, over here V2 volume. 1, 2, 2 what's happened? Volume is decreasing. Volume is decreasing and pressure is increasing. You can see from point 1 to 2 when graph will go, pressure is increasing. So it is which process? It is compression process. And it is which stroke? It is known as compression stroke. Clear about the compression stroke? In 122, what's happened? Pressure is increasing. Why pressure is increasing? Because piston is traveling from BDC to TDC. When piston will travel from BDC to TDC, so pressure is increasing from P1 to P2. Clear about this? Achha. After that, I will draw one perpendicular line with the x-axis. So it will be your 2 to 3. Now in 2 to 3, you can say like that. V2 equals to V3, you can write like this. Volume at point number 2 is exactly equals to volume at point number 3. Am I right? Now volume is constant. Volume is constant means what? Suction done, compression done. Now when piston is present on TDC, at that time this volume is not changing of cylinder. This volume is not changing, or you can say working fluid volume is not changing. And within that constant volume, what we are doing? We are supplying a spark. That means we are supplying the heat when volume of the cylinder is constant. So when volume of the cylinder is constant, we are supplying the heat. So I can draw one arrow like this, QS. Q means what? Heat. S means what? Supply. When you are supplying the heat in between point 2 to 3. Point 2 to 3 is known as which process? It is known as constant volume process. So name of process of 2 to 3 is what? Constant volume heat addition process. Clear about that? Now 2 to 3 process is not a stroke. It is only a process. 2 to 3. 2 to 3 means when piston is present on TDC, volume is not changing, volume is constant. That is why in a constant volume you are supplying this spark. That means at a constant volume you are supplying the heat. Now when you will supply the heat, so what's happened? Like this, I will draw the graph. So when you will supply the heat, so what's happened? Piston will travel from BDC to TDC. When piston will travel from BDC to TDC, so what's happened? Its volume is increasing. So V3 over here, that will be your V4 will be over here, point number 4. Volume is increasing, and if volume is increasing, pressure is decreasing. Because if volume is increasing, volume is inversely proportional to pressure. Pressure is decreasing. So pressure is increasing from P3 to P4. Okay. And later we will discuss that. And finally 4 to 1, what's happened? Whatever heat is there, due to the opening of that outlet valve, it will be rejected in the atmosphere. Once again it will go to atmosphere like this. That is your 1 atmospheric pressurized air initially you have taken during the suction stroke, and finally in exhaust stroke you are exhausting that. Now important topic to understand, process 122. In process 122, what's happened? You are applying the kicks like this. That means you are supplying the work. So W suffix S I will write. W, work is supplied. And 3 to 4, what's happened? Power stroke, because volume is increasing and pressure is decreasing. So in power stroke, what's happened? Work is rejected. That is why our vehicle can run. Okay. So process 122 is known as adiabatic process. Why it is known as adiabatic process? Because adiabatic process means what? That it is such a process in which work transfer is possible, but heat transfer is not possible. So that is why process 122 as well as process 3 to 4, both processes are known as adiabatic process. So what is the difference between process 122 and 3 to 4? Both are adiabatic processes. But what is the difference? Process 122 is known as adiabatic compression process. Why adiabatic compression process? Because in process 122, actually pressure is increasing, but it is an adiabatic process as work transfer with the help of kick. That is why it is adiabatic compression process. And in 3 to 4, what's happened? Power is produced, that means work is rejected. That is why it is adiabatic, but volume is decreasing, volume is decreasing. Volume is increasing and pressure is decreasing. That is why it is a expansion process. Simply you will remember like this. Process 1 to 2 is a adiabatic compression process, and process 3 to 4 is a adiabatic expansion process. So that is all about the completion of working of 4-stroke petrol engine with PV diagram. I hope you understood each and every point. If you are not able to understand, again watch this video, again rewind this until you will understand properly. Thank you.